Hello, this is a contribution from Kuzu Console to the Algorand ecosystem by Stephen Sunday and Seth Michael. In this presentation, we will learn how to develop a decentralized application in the form of a web application and a console app using the .NET framework to perform atomic transactions. Okay, so right here I have my Visual Studio 2019 open. I'm going to go ahead and create a new project. Okay, so we're going to create two project solutions. One will be a console application, the other one will be a web application, which is this two that we're seeing over here. So we're going to start off by first creating a console application with the .NET Core. Click on it and click on next. So the next thing you want to do is create the project name and then choose the location of where you want it to be stored. Having done that, click on create. So we can see in the screen our project has created successfully. So we're also going to create the web application inside the same project solution with the console app. So go ahead and click on this, right click on it, click on add and new project. So just like I explained earlier, we're going to create the web application this time around. So go ahead and click on it, click on next. Go ahead and rename your project. This is for the web application, so I'm naming it Atomic Transaction Web App. Name the project and click on create. So it will prompt us to create or select the type of web application we want to create. In this case, we want to create just a simple web application, but I'm going to go ahead and select the MVC web application with the model view controller. Do that and click on create. So our project has created successfully. We have the web application and the console application inside the same solution, project solution. So the next thing we're going to do is to right click on this. We're going to add the NuGet, we're going to use the NuGet packages to install our Algorand package into our applications. So click on manage NuGet packages for solution. So let's make use of the browse and search for Algorand. So we will see the Algorand package right here. Let's go ahead and select for all projects. So just tick on this the first checkbox. Check for the latest stable version, which at this stage in time we have the 0.2.0 version. So let's go ahead and click on it and install. Alright, so our package has successfully installed into our applications. Let's go ahead and cross-check that. Head over to the dependencies for the console application. Head to packages and we can see the Algorand package we installed. Let's do the same thing for the web application. Head over to dependencies and head over to package. You can also see the Algorand package has been successfully installed into both the console application and the web application. So back inside of our console application program.cs file, I have just added this code snippet below for our account creation, where we can create our account address and our account mnemonic key attached to that address. So first thing we did was to import the using Algorand statement or the namespace into our console program.cs file or the class file. And then inside of our main method here, we have an instance of our accounts, creating a new object called accounts. So this new object can have access to everything containing this account class right here. So if you hover over it, we can see our account.account. This is a method, an inbuilt function from Algorand itself with the package. So if you click on it, it's going to take us to this particular class where we can see everything that we can do with the accounts that we instantiated. So we can see it lists a whole bunch of additional built-in method or functions that can be used with it. So for this, at this stage, we're making use of this first one, that is the public accounts method. So back inside of our code here, we created a variable called address and made use of this account to get our account address. And then for the key, we created a variable called key, making use of our accounts to generate a mnemonic key attached to the account address. And then we have a console.writeLine here. This will print out the results that we want to print out. In this case, we want to print out the account address, which is what we're passing here, and then a new line, and then we're going to have the account address at the top, and then a new line below with our account key. That is our mnemonic key. So the next thing we're going to do is to run the application to test this out. So we're going to do this twice, or rather 3 times. We're going to run the application 3 times to generate 3 account addresses and their respective mnemonic keys. So to do that, head over to debug and click on start without debugging. Okay, so we can see our account address and the mnemonic key below. So go ahead and copy both the account address and the mnemonic keys. Alright, so we have our account 1, 2, and 3. And the reason why we created 3 accounts is because of the atomic transaction we want to perform. We want to have a main account, which is the main account that will fund the other accounts that we have. So in this case, we have 2 more accounts, which our main account, which is account 1, will fund. And one thing to note is this application is for demo purposes, for just tutorial sake, which is why I'm publicly displaying the account keys attached to the accounts that we created. Please and please never ever share your account key with anyone. With your account key, if someone gets hold of your account key, transactions can be made from your account without needing any other password or confirmation needed. This is a private key that should only be stored or kept in a private place and accessible only by the owner of the account or the user. So the next thing we're going to want to do is to fund this account address, which is our account 1, as the main account that will be used to fund other accounts. So to do that, let's head over to our browser, and inside of the Algorand dispenser, click on this checkbox for I am not a robot, and then paste in the account address and then hit on dispense. So we can see a code status of 200, which means success, and that also means that we have successfully funded our account address. Alright, so for the sake of reusability and also to avoid writing so many lines of code inside of our main method, I created another method right here called atomic transaction. We can see here atomic transaction method. So this is the method that is going to be responsible for atomic transactions. So the first thing we're going to want to do is to configure our Algorand API. So we're going to add the necessary namespace needed for Algorand API, which is the Algorand.v2 for the version 2, which is the second one right here. So go ahead and click on it. Alright, so if you hover over the Algorand API, we can see the parameters that we're supposed to pass in. So we can see we have a host and we have a token. So this is our host, which is the link running on PureStake version 2, and then we have the token, which is this right here, passing the parameters. So this is the first account that we created. This is the first account we are going to fund. This is the second account we are going to fund, and then this is the account key of the main account, which will fund other accounts. You can see here in the comments for all the account addresses and the mnemonic key. So we can see this account will fund other accounts. So this is our main account. All these accounts were created here. I just copied them and pasted them here. So right here we have made an instance of our account, passing in our account key. Remember earlier when we checked all the built-in functions, we had this as a method or built-in function passing in the mnemonic key. So that is what we made use of here, passing this account key of the main account that will fund other accounts. Remember I said with our keys you can make transactions. That is what enables transactions to run. So try as much as possible to keep your account keys private. I am publicly displaying this for demo purposes. So in case this is your first time seeing how a key looks like, an account key or an account address, this is how it looks like. So the next thing we want to do is to make use of our Algorand API parameter response, which is in short called it transparams here as transaction parameters. We have a try and catch exception here, making use of the transaction params, passing in the Algorand API instance the transaction params. This will get the transaction parameters for this transaction we want to make. So we have a catch of our API exception. So I'm going to go to add show potential fixes and make use of the using Algorand.client. So the error has gone. So in case we come across an error when trying to create an Algorand API instance, it will catch the error and then show this exception. Of course, this is the only possible exception error that we can get if we come across an error or a problem when making an instance of our transaction params, making use of the Algorand API instance rather. So the next thing is to create the group transaction. Alright, so when making transactions, the first thing we're going to want to do is to pass in the amounts that we want to fund other accounts. So in this situation, we have this comment is actually displaying what we're about to do here, or what we're doing. We're going to pass in the amount, so we're going to make use of the utils .algos to micro algos. This means we're dealing with micro algos, and after that we have our first transaction. So we have a variable called tx for transactions, making use of our utils get payment transactions, and inside of the get payment transaction we are going to have this parameter as our address from, that is the address from which we are going to make transfers from, and then our address to, that is the address that we're transferring funds to or dispensing funds into. And then we have an unsigned long integer for amounts and a string for message, and then finally our transaction params. So right here we have a new address, passing in our address, that's the main account address, and then the second account address that we're going to fund, the amount, and then the string message, which is pay message, and then the transparams. We did the same thing for the second transaction, passing in, the only difference is the account 1 and account 2. This is for account 1 and this is for account 2. So having done that, we're going to group the transactions, which is also known as atomic transactions, group transactions, atomic transactions. So making use of the digest, it's a built-in class or a function with the Algorand. So making use of the digest, we have we created an object called GID, that's for group ID, making use of the transaction group dot compute group ID. So this is going to group them together into a new transaction, passing in our transaction 1 and transaction 2, which is the TX1, TX and TX2 that we had. Down below we have our TX.assign group ID by the GID. That is the group ID. The same thing for transaction 2. Do the same thing. Alright, so having done that, we have a variable for signed transactions, making use of our source.sign transaction to pass in our TX. And we also have the same thing for the second transaction, which is signed transaction 2, pass in transaction 2 here. So we then have a try and catch exception. Right here we have a list. So let's go ahead and to show potential fixes and add the using statement, which is the using system.collections or generic. So we have a list of bytes, or a byte list. You can call it a byte list. That is the name we have over here as a new object, and then passing in our Algorand.encoder.encode message to message pack, passing in our signed transaction. Okay, so because this is a list, we can add as many as we want. So we're then making use of the byte list again here, .add range, passing in the Algorand.encoder.encode to message pack, passing in our signed transaction 2. So this first one was for signed transaction, which is the first one, and then this for signed transaction 2, the second one. So right here we have a variable var for the name here is ID, making use of our Algorand API instance raw transactions, making use of the byte list to array. So this byte list over here, we're making it into an array of type of array. So having done that, when if the try is works successfully without any problem, it's going to then print out this message, which is successfully sent transaction group with first transaction ID, passing in the ID here. Or we could just make use of this and then have it done this way. Alright, so we then have a catch exception in case we come across an error we do not expect. We have a catch exception error here, printing out exception when calling Algorand raw transactions and then passing in the message for that error. So having done that, that is the end of the whole atomic transaction process or group transaction. We are going to then print out this message saying that we have successfully arrived at the end of the test, and we should press any key to exit. This is exit. Alright, so one important thing to note about grouped atomic transaction is that once a single transaction or one transaction out of the other transactions fail, the whole transaction process will also fail. So we have to make sure everything is accurate. The transaction parameters, the account addresses that we're funding, we have to make sure that all those details are accurate. If not, the whole transaction process will fail. So in the browser, I've opened this testnet.algoexplorer.io link to be able to check our transaction details as they are happening real life when we run the application. So we can actually search for account address by the transaction ID or whatever among the list that we have here. So I have copied the main account address which we funded earlier on, and I'm going to search for it to get the transaction details or details about that account. Remember, we funded it earlier, so we should at least have a balance over here which is accurate. We have a balances of about 100 algos in our testnet account. So we have a total of one transaction. That was a transaction that we made to fund the account address. So because we are working on the testnet, which is why we have this testnet option over here in this drop down section. If we have our account on the mainnet, we can just switch to mainnet. If we have it on betanet, we can switch to betanet and see the account details. We also have the same thing with the wallet, the MyAlgo wallet, the iOS wallet, and the Android wallet. So for this demo, we're working on the testnet, which is why we're using the testnet option right here. Okay, so one thing to note is we have 3 tabs open. This is for the second account. This is the first account that we're going to fund, and then we also have the same thing for the second account that we're also going to fund. Okay, so back inside of our code, there is one more thing to note. I just added this line of code on line 80. This is our utils.wait transactions to complete. So this is actually going to make the transaction wait before it is complete, for it to complete before we can do any other thing else, or before even this message will show or display. Okay, so having done all this, we can proceed to make our transactions or to test run our transaction from our application. So let's go ahead and make pass in our atomic transaction method instead of our main method. Okay, so we just need this. So having done this, we can go ahead and run the application. Okay, so let's head over to debug. And before we do that, we can let's ensure that we have the console app as a startup project. So we can see it's our console application is a startup project. So we can go ahead and debug and start without debugging. Okay, so we actually forgot to remove the creation of accounts from our main method. But no problem though, we are not going to make use of the accounts. We just want this function to run. So right now we're waiting for the transaction to process and finish. Okay, so we have a transaction confirmation, and we have successfully arrived at the end of this test, which means our transaction has worked successfully. So I'm going to go ahead and close the window. So back inside of our Algo Explorer, we can see our balances for the first account is 1, and then the balances for the second account is also 1, which means these two accounts have been funded successfully, and then our main account has been deducted. We can see the transactions that were made. The first time we funded it, the second time we funded the other two accounts, and then included with the fee, that is the charges attached to the transactions. So we have successfully performed an atomic transactions with our console application. So the next thing we're going to want to do is to implement it on our web application. So to do that, let's head over to the Solution Explorer. Remember, we have two projects here, the console app and the web application. So we use the console app to create our account address and the money key, and then we perform the atomic transactions. We're now going to use the web application to replicate the performance or the functionality of the atomic transactions, but this time around on the web application using the Algorand protocol. So let's head over to views, and let's open the folder and also open the controllers folder. So inside of the home controller, right here inside of the controller, our index view by default is the startup view when we launch our application. So I'm going to head back to the program.cs class and copy this whole atomic transaction method. Go ahead and copy the whole method, and then inside of the home controller, I'm going to paste it under the iAction results for the index. And then I'm also going to add all the necessary namespaces, the using namespaces that we used for this console application. So we need the using Algorand, Algorand.client, and Algorand.v2, including the system.collections.generic. So I'm going to go ahead and add them up here. Okay, so we already have a system collection generic, so I'm going to leave this tree the way they are, and as a result of that, all our errors have gone, they have all disappeared. So the next thing we're going to want to do is to pass in our atomic transaction method into our index view, so that when our index view launches or starts, it's also going to perform the atomic transaction. Or rather, I will do it in such a way that we're going to create a button and then click on the button to perform the transaction. So I'm going to go ahead and just delete this. Alright, so I've made some changes to it. This is now an iAction result. This is going to be a method, but we're not going to create the view for it. So whenever we call this method, we're going to have a button for event handler to handle whatever happens whenever we click on this atomic transaction. So when we click on the button for the atomic transaction, which is this class over, which is this method over here, the whole transaction will should work. And then we have made a couple of changes. Instead of console.writeLine, we have a temp data. This is going to pass in a message back into our web page on our view inside of the index view, displaying this message. All right, and then also this message here for this successful ending of the whole process. And then at the end, we have a return, redirect to action. It's going to take us, after performing the method, the transaction of the method, is going to redirect us back into our index view, which is this view right here. And this is the page for the view. So I've added a temp data if condition statements that if it is not equal to null, then it should display whatever message we have instead of where the temp data is. And then right here we have, this is the form for our button. The button is going to display atomic transfer, and this is going to be the name of this method over here. So I'm going to change this to what we have there. Alright, so having done this, we can then go ahead and launch our application. We can delete all these other necessary codes that we don't need. I'm just going to leave them like that so we can also see our button underneath. So having done this, go ahead and change the startup project to the web application and launch the application. Okay, so before we run it, I'm going to change it, the startup project, to the web application, and then click on this IIS Express to launch the application with the debugger. Or rather, to make it faster, I'm going to start without debugging. Alright, so we have our web application up and running. So I'm going to go ahead and click on the atomic transfer button. Alright, so we have seen our message, and that means our application has worked successfully without any problems. So let's head back to our Algo Explorer and check what we exactly. So we can see another transaction, in fact 3 transactions. I tried running it twice when I refreshed, so that's why we can see 3 transactions over here. So I'm also going to go ahead and do this again one more time to show us how it works. Alright, so while it's loading, I'm going to go over here. So we can see 4 now, just about 17 seconds ago. And same thing with this one, which means our application has successfully funded the account. Everything has worked successfully. So we have achieved what we wanted to achieve in this demo. We wanted to make an atomic or group transactions, and we have successfully done that.